So good day guys, this is CHI-BBT. Today I'm going to be teaching you Laplace equation with electricity and potential. If you are in Faculty of Sciences, if you're in engineering, if you're in physics, you need this class. If you're in year 3 or final year, anywhere in the world, because I'm teaching you world-class standard. Check me, ask your professors, take my videos to any professors in the world. It's CHI-BBT. So today is a different ball game. This is what students just cram a lot, or maybe they don't get enough knowledge in school about it. So I'm going to bring 3 things to your notice. Tell you about the Gauss law, tell you about the Poisson law, and then tell you about the famous Laplace equation. We are not using integral today like my previous videos. Today we are going to use what we call the differential formats, the general format for Laplace equation like this. So guys, stay tuned. So today we are going to do Laplace equation with electricity and potential. Please don't forget to subscribe to my YouTube channel to see more videos. Always share my videos and repost. There's something I didn't say to you, and that is we are dealing with electrostatic. Electricity. Join me through the journey. Let us prove all these equations. So our goal today will be number 1, getting the Gauss laws. Number 2, we are going to get the Poisson equations. Number 3, we are going to now get the famous Laplace equations. Let me just add this one because this is the main thing, right? Number 4, electric field and potential. So first of all, we have to start from the beginning. The first electric equation, E equals to 1 over 4 pi epsilon naught. Then the integral, this is the arrow in vector form over r raised to the power 2. And this is the charge density in displacement domain. And this is the z. This is equation 1. Note this equation, equation 1. Now we have to consider the relationship between electric field and potential. This is the equation equal to E equals to minus dV over the r, equation 2. But the v over the r can be replaced with this Laplacian operator. This is a Laplacian operator that shows first derivative. So put this as equation 3, right? So now substituting this back here, what we have is electric field equals minus, then the first operator, then v is the potential. So this is number 4. Just say this is equation 4. Now that we have this equation, we begin to reason. Now there are 2 things. There's the Gauss law. The Gauss law states that the electricity is proportional to there's this thing called charge density. The electricity is proportional to charge density and over permittivity. So we have something like this equal to the electricity proportional to charge density over permittivity of free space. Equation, see that equation, this becomes equation 5. Now we're trying to get the Poisson's law. We cannot get the Poisson's law without considering the conditions Maxwell stated from Gauss law. I already stated Gauss law from you, but Maxwell's condition for electricity is electricity equals to electric charge density over epsilon naught. That's the first law that Maxwell stated. Second law, he stated that, and he stated it in Laplacian form. E dot this, then Laplacian operator dot E means first derivative. All those things means first derivatives equal to 0. This is Laplace. So you can decide to bring it down. The first one is in the presence of charge. The second one is when charge density equals 0. So bringing it down here, we have an equation like this. The first operator equals 0. And also an equation like, just leave this equation. Let's call this equation 6 altogether. So now let's get the Poisson equation. How do we get the Poisson equation? We have to simply take 4, substitute it into 6. You know that E equals minus the Laplacian operator, then V, which is the potential. If we take this here, what we have is dot this. That's this first operator dot whatever is here. This is minus because E is equals, and this is E bracket minus this operator V. Then you close the bracket equal to 0. So what do we have here? We now have plus this V is equal to whatever multiplies 0 divides 0 will always give you just 0. So this is the famous Laplace equation. And now note, to get this Laplace equation, the charge present in that field of potential is 0. Now, for us to get the Poisson equation is like this. Just take this equation, bracket minus this operator V, right, is equal to electric charge density over permittivity of free space. When we break it down, we have second operator. This means second differential equation, raised to power 2, you know, then V equal to, this minus definitely will be here, but we'll still take it to the right answer. Well, when we take this side to the other side, what we have this equal to minus this over this. This is the famous Poisson's equation in the presence of charge. In the presence of charge. So this is how to prove it. So no need of cramming. This is your final answer. Thank you all and see you in our next class. I want to see you on YouTube.